Welcome everyone to our second webinar on low impact development with segmental retaining walls. I'm Keith Miller, your host today. Our presenter today is Dan Tix, Director of Technical Services. Dan is a licensed professional engineer with 16 years of retaining wall experience here at Keystone.
Good afternoon, everyone. So what we will be talking about today is low impact development, and some of the topics we're going to cover. We're going to go through terms first, and then we're actually going to walk you through a bunch of examples and details that have been put in plans. Low impact development has obviously been around for quite a long time now, but it's starting to gain traction across the country. And we did start doing some of these types of presentations around 2017 as cities, counties, states started implementing these low impact practices and starting to provide handbooks like this one here for providing guidance for designers. And that's what we're here to really try to do today, is provide everyone guidance on how to handle it when you're looking at these applications with retaining walls. And we're going to cover a variety of applications. So what are these low impact handbooks? And what they do is that they kind of provide, local designers, engineers, architects, landscape professionals, contractors, how to implement these practices within their current stormwater guidance, right? And the reasons for this is, they're believed to be techniques to help reduce runoff, increase groundwater recharge, and improve water quality, right? So the impacts to the environment are a lot less. We're recharging our existing water supplies, things of that nature. And so these are a little bit more common, hopefully getting to be a little bit more common practice, more widespread practices throughout the US. The goal of the low impact is to protect water quality by preserving and mimicking natural hydrologic functions through the use of stormwater planning and management techniques on a project site. A lot of handbooks are going to be a lot different. I reference here the County of San Diego one, which was very useful, as they were one of the first to kind of start implementing these low impact design or low impact development guidelines. Goals, right? Come up with land development strategies that emphasize conservation and use of on-site natural features, integrated with engineered small-scale hydrologic controls to more closely reflect pre-development hydrologic functions, okay? And really what all that boils down to is our goals right here. Protect water quality, reduce runoff, reduce impervious surfaces, encourage open space, protect significant vegetation, and reduce land disturbance. So instead of creating large-scale retention ponds for stormwater runoff, we're allowing it to infiltrate into the ground, or we hold it to infiltrate it and we're filtering it before we send it back into the ground, and thus reducing the amount of space and making hopefully more usable space on a site as well, but reduce the amount of impermeable cover, because then that produces more burden on our current stormwater systems. So that was another goal, is really kind of help reduce, when we talk about these integrated management practices with low impact designs, is to help reduce some of the burden on these growing developments, especially in these cities where, water treatment facilities can't handle the large burgeoning populations. And so we try to come up with some different ways to impact these newer developments that reflect in the stormwater quality and stormwater management. So this is a chart of the County of San Diego handbook, and where they identify who should be involved. Obviously you have your stakeholders, right? Your land development, your local government, your community, the water authority, the business industry, but then you also have the design team. And, on there is one thing I would say is that they're missing is, your civil engineers, your designers, your people that are going to be doing the actual work on this multidisciplinary design team, to get involved early on. They probably more likely wanted to identify them here when they're getting into their land use plans and treatment, and then get into the stormwater. But if we believe, and this goes for anything, whether you're doing a retaining wall design or anything else, the more parties you have involved to help mitigate costs up front, the better off you'll be. The basic lid strategy is of low impact development is to reduce the volume and decentralize water flows. It's best accomplished by creating a series of small retention or detention areas that allow localized filtration instead of carrying runoff to a remote collection area for treatment. These are known as structural low impact development integrated management practices and may qualify as treatment control for your best management practices if it's properly utilized. And a lot of counties are now going to these best management practices manuals, and they're all tied together, whether it be for stormwater practices, for site development, industrial development. All of those things end up being tied together, or a city's comprehensive plan, which ties in with the best management practices. How do we implement all these things as we go through our various stages of development in future years? Where you might find segmental retaining walls within these low impact developments. Obviously, bioretention and bioretention swales are going to be big ones. Permeable pavement, flow through planters, vegetated swales, vegetated filter strips are all possible areas where you might end up utilizing a segmental retaining wall. What we're really going to focus on is where probably 80%, 90% of our work is in this bioretention bioswales area. Additionally, we also have, more use with permeable pavements, where that's permeable concrete, permeable interlocking concrete pavers, even permeable asphalt, all those types of things that are reducing the amount of considered hard coverage area within pavements, parking lots, sidewalks, those types of things. And then finally, vegetated swales. So bioretention. So what you need to know is, are we filtering or infiltrating? So filtration would be is where you're filtering it, but you're still kind of sending it part of the stormwater to the stormwater management system. Infiltration is we're allowing it to percolate through the site. And so what we say is we have a flow chart. Okay, is infiltration permitted? Yes or no? No, we go with a specific configuration of our bio retention area with under drainage, a filter plus under drainage, and it's also a self sort of contained unit that sends it to sort of like a pre-filter to the stormwater system. If we are allowed to infiltrate, what is, we can move to yes, is it greater than 1/2 inch? And this is per the San Diego rules. This is what we had to go with for right now for this presentation. And the infiltration rate may be different in other areas per their stormwater guidance. We would go with a configuration 1, where it's an infiltration with no drain. If it's not greater than that, but you have some infiltration, well, what other kind of configuration do we need for the infiltration? Is it partial infiltration? You need to determine what percentage you might allow as infiltration versus what's going to the stormwater center. And so that will dictate the types of details that are going into the bioretention. And here they are. So configuration 1 would be the sort of this biomedia with an outlet structure for overflow, but most of the water is contained in this biomass and then allows the filter into the ground. Configuration 2 would be with an upturned drain, where you're still allowing some of the infiltration media, but you're picking up some of the water as well, which may go to the outlet structure. Configuration 3 is the infiltration with an under drain directly on the subgrade, and it's holding more water, right? So it's actually, the subgrade is probably less permeable than configuration 2. It's holding more water, so then you actually have a greater amount of water that's getting caught in the drainage system. And then finally, the 4th configuration, where you're just doing a strict infiltration. You see that it's a sort of a self-contained unit with these impermeable liners, whether that be a clay liner or some type of PVC plastic liner. On to our example. So here we have a project where we have a retaining wall that's supporting the parking lot here. You can see our grades 49 up here, and our inverse down here for the collector pipes is around 37. We can see we have a little slope, and we have this wall to kind of self-contain in front of this basin. Now, some of these basins, they may have reduced volume ratios, right? Because of what they are doing, they're allowing the water to infiltrate. That all depends on your county requirements. But here we have a wall that's kind of self-contained one side of the berm to hold up the parking lot. The designer noted that they're probably going to utilize a modular block retaining wall, as a lot of these site developments are we are getting more prevalent in being noticed on sites as the retaining walls of choice. So they noted that this is going to have an 18-inch thick planting bed with a sand layer and then the gravel layer below that with an underdrain system. This one has an underdrain system with a filter fabric. It's sort of that partial infiltration note with some of those pipes you'll see here, those drain pipes. Take note of the planting bed material and what it actually consists of. You know, 85, typically these biomass material is 85% sands, 80 to 95% sands, no more than 15% silt and clay, because you know you want to allow the water to filter. And then they're adding organic material to it to kind of sort of eat up some of the contaminants in the water. The mix must be certified, and you know, it shall be placed in 12 to 18-inch lifts. Now, one thing that's not noted here is a lot of these are actually placed in loose lifts, right? They want the material to allow to condense over time, but they want it to be loose so that when water comes through, it's allowed to actually filter through. So there's generally no compaction requirements for this, or the compaction requirements might be very, very low. You'll notice here the contractor shall use rubber tire or light duty equipment within this area to minimize the compaction of the underlying soil. On the same plan details, they also threw in the typical details here. You know, they'll have some detail that a lot of the plans will just have some detail that they've had over time. They might not necessarily have gone and updated their typical sections, or they've come up with some of their own details. But this is a lot of time what happens on the job is they throw in some type of typical detail. You'll notice here that they have a large free draining clean crushed stone zone. They might have a fence, guide rail, the batter of the block that they supposedly want, or that was just noted in the typical detail. But then you'll see down here, you know, a copy of the manufacturer's cut sheets for retaining wall must be submitted. Contractor is to install the wall in complete conformance to the manufacturer's requirements and recommendations. Structural calculations are required. So that means, you know, we obviously have to produce a set of plans, okay? We want to make sure that we note that we incorporate these types of details, right? You know, this is not noted out here, but this is where they note that there is a retention area. They also noted that their outflow pipes are going to be entering this area, so they actually detailed this out pretty well and types of details that they want per their requirements with a concrete head wall, and having a horizontal bar to brace the wall over that. Now, whether or not that, you know, that's done on every job, that's a sort of an individual detail. So what I bring up is what's missing, right? What is missing out of this whole situation is that there is no typical cut sheet for this types of situation. It's sort of brand new. They utilize a typical wall detail, but did not specifically address the wall details for this particular project. Right? They probably should have combined sort of the biomass details within the typical section so that people could see what they're actually dealing with. There was some concern with that section and the amount of embedment at the wall. They didn't really address what was happening at the bottom of the wall. Placing these walls in a sort of a uncompacted material that's not meant for structural capacity is the biggest concern. We want to be able to protect the toe of the wall because it's holding up the parking lot from erosion, protection, and stability. There's also maintenance issues with these bioretention areas. The good details, you'll notice that they did utilize the filter fabric around the planting material, and they addressed the pipe outlet. And you know, why is it important to be specific in these details? Well, number one, the contractors are bidding directly from the project plans, right? You'll notice the first note on that previous section was that They had to provide manufacturers cut sheets. They're bidding this probably before they have a design because they noted that the contractor is to provide a design. So they may not contact a wall manufacturer to understand that additional attention is necessary for a wall type like this. They may not reach out to Keystone to figure out if additional block might be necessary at the bottom of the wall, or that there's a lot of new filter fabric that needs to go in. Does the pond hold water? What types of backfill are they going to need behind the wall if this is going to actually have some water inundation on the wall face? All of those types of things add cost to the wall, whereas if they had it up front in their bid, they wouldn't do it and you wouldn't be getting change orders on the back end. Our second example is another bioretention one where it's actually fully encapsulated. So we have a retaining wall all the way around these biomass areas. And we have one over here with an outflow riser. We have a larger second one over on this side in the berm. You'll see plenty of utilities coming in from the various areas on the site. And this detail is actually slightly different. Okay, we have a typical wall schematic. I've highlighted a number of things within this one. Here they actually have the, so we noticed that the top of the wall is at 455. We have our 100-year elevation of the water at 453.83. The 10-year is just below that. And then the 1 year is just below that. So there isn't a great change. So there's going to be essentially constant water in this particular application. In this application, they want 2 to 4 inches of surface layer to be shredded mulch. You'll notice that they have this arrows for the planting soil. Here is 30 inches of material, 2.5 feet of material. That material is sitting over 4 inches of wash sand, over another 8 inches of stone. You have some types of risers that are basically overflow structures that outlet to the storm system. They have their outlet pipes. So you'll see here that you actually have roughly 3.5 feet of material going into each of these ponds. The one thing you don't necessarily notice is that you don't notice where they've actually defined where the bottom of the wall is. You know, they kind of cut it off here, but it's relatively unclear in this particular detail what's happening with these walls. And that's important because of what the walls are holding up and what's in front of the wall. You'll note that they actually define the soil medium here. Again, it's a soil mix, 85 to 88% weight of sand, 12% fine silt and clay, and 3 to 5% organic matter. And that's different than the last one. Everyone has their own material that they want to be placed here. This is the detail for the second pond. A lot of the very similar details. The only thing you'll notice is that there's a slight water change here. There wasn't much change between the 1 year to the 100-year elevation, but there is a constant water elevation, and that's all. The water looked to be relatively within less than 2 feet of the top of the wall surface, or the top of wall. You'll notice that they're actually planting specific types of plants in here. 1 tree, 3 shrubs, 3 herbaceous species shall be planted. Okay, where are those going to be planted in relation to the biomedia? Are they going to be in the middle of the pond? Or are they going to try to plant them next to the wall face? Where are those areas going to be planted? So this particular project example didn't have a typical wall section, although the job ended up being a segmental retaining wall, but the wall type details weren't noticed. Wall details at the bioretention were missing. How do you handle 30 inches of biomaterial? How are you going to handle the various pipe sizes coming through the wall face? The plans did not address specific fabrics and liners. So there was a lot of those cost details, a lot of overall details of what's happening here. Now that may have happened further down the line as they got into construction and things of that nature. But again, it might have been better to have known some of those things up front versus trying to handle them as you get down through the cost of the constructions. So what does Keystone recommend for these types of details? And so we've come up with a number of details that specifically address these biomedia, bioretention, detention areas. And a number of details, and these are available for use. And for typical details, we address what we consider the important aspects of doing these is at the bottom of the wall. So this is our first detail where we call detail A, where you sort of have this infiltration process. And the one thing you'll notice is that we put our bottom of wall, we embed it significantly deeper, and we actually put it at the base of the structural layer. So 57 stone is a structural layer. 57 stone is the same material that can be utilized as our unit drainage fill back here. They're using it as a sort of a filter medium, okay? And they're using it as a stabilizing foundation as well for this material, so that when they do run equipment on it, they're not sinking completely through the planting media, right? They actually have something to utilize for maintenance equipment. You'll notice that our pad is sitting right about even with the wash stone layer. We do have our own water filtration, or our own water pipe that outlets to the filter media, the biomass. And so we are significantly lower than, say, a normal wall, right? Typical wall embedment for segmental retaining walls, as a rule of thumb, is 8 inches or roughly 10% of the wall height. And that, then we're not talking about toe slopes or slope stability and get into any of that today, but this is the rule of thumb. And so when you're talking about, you know, an 8-foot high wall, or even a 10-foot high wall, 10-foot high wall, you're looking at least a foot of a minimum embedment criteria. Well, here we're getting down to the foundation layer that we need to bear the wall on that's stable, right? We cannot bear these walls directly on the planting media, as we kind of talked about. There is no structural capacity on that. And we want to protect the base of the wall. Our next detail would be more of an optional detail, and I would say that this is probably not utilized a whole lot, but the reason I kept it in here is there may, I have an example where this may be a more suitable application for it, where you're actually placing a structural aggregate layer in front of it that isn't included as a part of the bioretention area. So what we end up doing is while it saves you a little bit of embedment and an additional block to get down to this drainage layer, you're placing a well compacted, you know, minimum layer of structural fill, typically 2 foot wide, on a 1-to-1 slope away from the base of the wall. And that gets into that sort of toe protection area, stable base, and to help resist sliding. We're actually putting the wall facing on a near a competent material, well compacted material. Same details as before. You might have a filter fabric that extends up the face to kind of sort of prevent that biomaterial from filtering through to the wall face, things of that nature. Our next detail is for a typical high water. So if you know you're going to have water levels well above, or even some version above the actual planting media, we're going to want to have that free draining aggregate within a reinforced zone behind the layer wrapped in filter fabric. So the filter fabric is going to come up to that high water level, the 100-year water level, and extend back here to the end of the reinforcement, wrap itself around. You might wrap it up this face or down around this part of the leveling pad, then up the face, but we don't want this media coming back through, filtering through here. We want to keep this as free draining as possible and allow the water to move freely from the face. We don't, you know, our wall faces don't stop water. We allow the free movement of water with the aid of a 57 or 67 clean crushed stone. So we sort of, you'll notice that each of these details, we have a significant amount of embedment. So why the deepened embedment? Oh, let's explore that a little bit more. So the planting media has no shear strength. It's no, so essentially putting the wall face on even near the face of that wall, and you get part of it on the shear, the planting media, you have no sliding protection, okay? And that's only if normal embedment protocols are followed, right? There's no means to support the wall facing. You can have additional issues related to settlement, you know, rotation of the bearing of the reinforced mass because you're having settlement near the face, things of that nature. Most importantly, though the embedment is protecting the wall base from scour erosion. You're in an area where water is moving, albeit at a lower rate than, you know, say a channel application or something along those lines. But you do need to protect the base of that wall. And a lot of the time these walls are supporting parking lots and things like that. So it prevents us from having issues at the base of the wall. And then finally, the maintenance protection. The average lifespan of this biomedia is roughly 3 to 5 years, depending on the use. And so within these bioretention ponds, they actually have to come out, remove the old media, and replace it with new media so that it acts more properly for the filtration process. Whether you're doing filtration or infiltration, eventually that media needs to be replaced. And so if the wall is sitting above the media, the base of the media, and they dig down below that, you can have some significant issues at the base of the wall with undermining that wall face. And that's where we need to maintain the structural integrity of the wall, and therefore we need to pull the base of the wall down to those structural layers, or at least well below the bottom of the planting media. So let's get into some additional details here. So we have this project that we referenced on the title page. This is actually done in Maryland. And this is some bioretention details, but we actually utilize it for the permeable pavement details as well, because they designed a permeable pavement section sitting over the stalls area here. So we have our outlet pipes, and how do we address that? Well, typically anything less than 24 inches in diameter, the drain units can be cut around the pipe as shown here. Now this actually takes some skilled saw work and some skilled work with a diamond blade to get it to fit properly around it. Round pipes are generally harder. You can put in some type of concrete collar where necessary, and we recommend those just from the standpoint of ease of use and ease of construction, and making things look better as well. Here you see the actual individual wall drains. This is a raised drain detail where they're outletting directly to the biomedia material. Structures near the wall. So if we have one of these outlet structures and we have, say, a pipe that's coming, that's leading away from the site or coming out this way, you'll see here that actually the pipe is coming, going this way to the site. It's not leading out, it drains in and drains out through the parking lot actually. You're going to have a rigid inclusion in these types of structures. And so what we recommend is that you need for this section of the wall, here you can see they actually poured because of the size of the pipe, they actually poured a collar. They match the coursing level. Now you can get within roughly an inch and maybe do a grout set mortar layer to adjust to your coursing level as needed, but you're matching the coursing of the wall as best as possible. The contractor then saw cuts a joint, and typically these joints are lined up with the ends of a block above and then the middle of a block below. So this gets saw cut and the joints get saw cut, which allows for each side of the wall to settle, because the wall, this part of the wall, this side and this side on the other side of the structure are all sitting on natural subgrade, whereas this part of the facing of the structure is actually sitting on that pipe and rigid head wall. And so this part may settle differently than these two. So this saw cut joint allows for the face to shift without cracking, and the cracking actually occurs in sort of this pre-cut joint that we put in. Now I know you all must be asking, okay, we've gone through what biomaterial can be done in front of a wall. Can SRWs be used to support bioretention? And so I'm going to present some of the challenges here. So the number one challenge is we're introducing water to the behind the wall. And if we go back to our flowchart processes, what type of water is this? Are these typically going to be? Well, we're always trying to, at best, do infiltration, and rather than the filtration version when we talk about low impact development. So we're allowing water to commit to the system. SRWs do not stop the flow of water, rather they permit the free movement of water. So we're not going to necessarily stop any water movement to be contained in the filtration media. The depth of the biomedia is certainly an interference criteria for the wall reinforcement. The biomedia doesn't have any shear strength. the geogrid should not be placed in any biomedia. And how do you detail that those types of walls? Where how far away does the retention area need to be? Things of that nature. When I say up here, removal considerations, we're talking about the water. What kind of additional drainage provisions to protect the structural integrity of the wall would you have to do? So those are some of the concerns and challenges. What we say is, number one, if it's all possible, it's best to avoid using SRWs to support bioretention areas due to the introduction of water behind the wall. However, should there come a time where no solution presents itself for a different wall type or something of that nature, what are some things that should be definitely considered when going through this in your flowchart process? Well, number one, what to avoid. Obviously, the bioretention should not be directly behind the wall facing. It probably shouldn't be done for any large scale walls greater than 12 foot high. The recommendations for the biomedia, there should be some minimum offset distance away from the wall. What we would recommend at the minimum distance be at least a wall height away. So if you have a 10-foot high wall, we would recommend that the biomedia retention area be at least 10 feet away. Okay, and part of that is due to allow the water to dissipate in the area around the bioretention and filter down, and it gives the retaining wall designers provisions for putting additional drainage capacity behind the reinforcement so that it can collect the water before it actually gets to the wall face, right? Whether that be some type of geocomposite drain at the back of the reinforced zone or some type of aggregate chimney vertical drain to some type of pipe collection system. There also the possibility where you're utilizing impermeable liners. Free draining backfill is also going to be a recommendation, obviously, in case water does get there if the additional drainage provisions aren't implemented. You're going to see a lot of different costs associated with doing that, and the liners would actually prevent the water from going towards the wall face as well, but they can be a costly and difficult to install option. So actually, I have a project example regarding this. So here, I apologize for the the detailing here, but what this says is bioretention. This is an existing. You'll see some existing details here. Bioretention treatment area, top of soil 98, roughly 1,700 square feet of area. You'll notice some details here. Top of wall. This is an existing grayed out wall right here, and here's where they planted the bioretention area. Now, a lot of these, as site developers go and as civil engineers go, they end up putting a lot of these things at the edges of a property, the site developments. They're always hanging out at the edges, whether it's a fill wall where we're supporting it or a cut wall where it's placed in front of it. All these bioretention drainage facilities tend to be on the outward sides of the property so that they can put in their buildings and parking lots and sort of in the prime real estate, if you will, of the property. Or the walls are doing their job and making more prime real estate. Here's a detail where the contractor noted the existing wall from the previous thing. Here's the new wall that they're going to put in. And then, of course, the biomass area. With their drain, you'll note that they call it a 10 millimeter visqueen or impermeable liner up the face of the new wall. Down the back face of the existing wall, keep in mind that this wall is already in place. You have 18 inches of material behind this wall, 18 inches of material in front of it. Might be a little bit more to create that slope, plus the drain behind it. There is no depth indicated here. They just kind of put their details together. They kind of talk about the subdrain details. Okay, so bioretention facility, and they actually call this one a facility versus a retention area or pond basin. And here's what this actually was. Here's the actual site development. We have the existing wall here. We have the new wall shown holding up the parking lot. Grades coming down this way slightly. We have a big hill up here where everything kind of flows down this way. We see the wall that's actually going to have the biomass in front of it. This is all new wall. And when you actually get out to the site, this is what the existing wall is. It's an existing segmental retaining wall from a previous developer who started the site development process, didn't complete it. The new developer came in, made new plans, picked up where they kind of left off, but did not check back to see what that existing wall was, and didn't have the engineer go visit the site to see what that existing wall was and whether it was capable of doing this situation. And unfortunately, in this situation, the segmental wall was not going to be suited to handle that type, and nor was it likely designed to handle the load conditions of the new set of designs. So always need to check with the wall designer on the wall capabilities and what is the best type of wall situation for your particular site development. It can be done if we follow, our previously stated recommendations. Unfortunately, the new site designer assumed wall was suitable for support. The utilized detail is not appropriate for that wall type, and there is no standard details for this type of application. Bioretention swales. So these are very, very common. You'll see them a lot in these where you have these parking lot aisles here. This is actually one in Minnesota where they sort of created this drain to a biomedia swale, which then goes eventually to an outlet structure. Same dissimilar details as the retention pond. You have some type of forest style configuration for infiltration with some water, infiltration with drain, or complete filtration to a stormwater system. Our Bioswale example is actually a variable drop bioswale system with a series of check dams, concrete check dams. And here you'll see the actual segmental retaining wall holding up the hillside away from the bioswale. Here we have the weir structure details. I call it check dam, but it's a weir structure, a full-on concrete weir structure integrated to the segmental wall. Here we have a detail that the engineer put together, where you have 24 inches of biotreatment media over 18 inches of perforated rock. I'm not sure how this was going to get accomplished with the wall sitting directly above, and you're going to have a vertical joint here with 12 inches minimum of compacted material between the biotreatment area and the wall face when you have that little room there, especially when the excavator has to come down 3.5 feet to dig out the area for the bio area and then install the rock and have it all self-contained. I just don't think this is a feasible option. Okay. They did a slight wall profile. You can see that the structure goes all the way down to the base of the biomedia. It actually self-contains it up here. This weir structure needs to be self-supporting because obviously this is going to act with water on it, so it needs to be able to withstand this zone here. That is typically separate, done by your civil engineer or structural engineer. And you have these various cell containment units as we filter the water down through the site. So what's missing on this particular application? Well, wall embedment depth. Where are the wall drain outlets? Material between the biomaterial indicates undisturbed or native. This area is going to be disturbed. And plan view shows pipes, cross sections do not. So there's some cross detailing references that we need to get to. We could utilize this particular detail, and this is what ended up being installed, only down the 3.5 feet or the 2 feet to the stone layer. That previous typical detail would be probably could have been an option because they obviously wanted to have not as much embedment where they're showing that 1 foot zone of compacted material. So typical wall detail B probably could have been utilized if they had moved the swale out a little bit or allowed the swale to have that compacted structural material there. In place photos, you can see here the kind of the final picture. We have our drop as we go down the site. Not too crazy of a vertical change here. You can see the filter fabric coming up the wall face, the actual concrete weir structure, and they're starting to place some of that biomaterial in the areas in front of the wall. Here we have what's the typical detail. We need to have some type of fabric to contain between the two walls, and this should be a construction joint material or a construction joint between the wall facing. So we're going to have expansion joint material to allow these materials to move independently of each other between the two structures. Another good photo of the side of the wall here. Contractors pinning the fabric up the face with the block, and they're getting ready for final biomaterial placement and constructing the pavement out front here. You can see a little bit better picture to see the actual vertical drop coming down the site. Permeable pavement and walls. So this is actually a little bit different than what we've kind of been talking about. We have a couple of different things. You have typically you have a detail for a pervious concrete, pervious porous asphalt, or permeable interlocking concrete paver. I would probably say that the permeable interlocking concrete paver is actually a little bit more common than the upper two. So they're going to have slightly different details. But each county is going to have their own details for how to handle these various situations. And the reason I bring these up is because a lot of these applications, here's their four configurations for how to handle it in various pavement situations, is that it's getting to be more prevalent and that the walls are holding up these permeable pavements, right? We're at the edges of the property, we're supporting parking lots, we're supporting driveways, and this is where they want to utilize it. So here we have this media that's being infiltrated behind the wall. It's actually structural material under here because it's pavement, right? It's not biomass. So we're just sort of filtering the water, if you will, or collecting it and sometimes potentially holding it depending on the type of application. But what I want to get to is these details because we are supporting these types of applications. We're still not going to put it in these reservoir layers, and the reason for that is we typically have either a filter fabric here, right, or some type of hydraulic restriction layer, whether that's our visqueen or impermeable liner. And in this case, if we're doing a segmental retaining wall supporting a permeable pavement, we want to make sure that it's a hydraulic restriction layer. Okay, we want to keep the water in this area and actually drain well beyond this area. One of the things you'll note is that there is plenty of other details that will go in behind the wall, whether it's a guide rail or some type of fence. You know, we'll come back to this photo with our previous project example, where we have our wall out here, we have a fence, a guardrail, a curb, we have that inlet structure, and then our permeable pavement. And so there's a lot of things that we need to be able to handle. The upper reinforcement layer, it could be one, it could be two layers, but each layer can be skewed no more than 15 degrees to avoid the reservoir layer. And typically that is enough to avoid this layer. And these layers, obviously the thickness changes, but typically they aren't over 18 inches. So by the time you add in enough offset for the other details, we have enough room to skew the grid down. We have the hydraulic layer that's protecting us from pushing water into the base of the wall. You'll likely have to do an additional drainage system down here as a safety precaution to catch any potential water that leaks out of this system. You might have a pipe back here, even running to the outlet, something of that nature. Every site is going to be unique. Every site is going to be different. And so those types of details are going to need to be determined between your civil engineer and your actual designer, your wall designer. Walls, you know, we need to prevent any development of hydrostatic forces behind the wall. Our segmental walls are designed to prevent that development of hydrostatic forces behind the wall with our free draining aggregate system, but the implementation of additional drainage provisions is certainly going to be required. Another big thing is pay attention to the site soils. The site may only provide for filtration and the storm runoff may need to be collected. The wall designer will need sort of that information as they're proceeding with their design, so that they know how to handle the water that's coming out of these permeable pavements, and that we can actually handle it from a properly structural standpoint in the retaining wall design. And again, I highlight it here. Geogrid at the top of the wall needs to be skewed, as the walls are typically completed prior to pavement installation. And so we need to make sure that the installer knows that has to skew this and how far it is. So accurate representation in your surveys, knowing where the curbs go, what elevations are going to be placed at, what is the bottom reservoir layer of the permeable pavement. Those types of details are critical when determining putting these permeable pavements at the backs of the walls for support. And one of the biggest things that we see, and this just goes for regular pavement, is more often than not, the pavement contractor doesn't know that there's a structural layer there. The geogrid is located directly below that, and they end up, when they come in after the fact, dig out for their parking lot base, curb, things of those nature, they actually end up cutting into those grids. And so it's very important for the wall installer to know that they need to get that skewed down. And it's probably very important for the pavement, before the pavement even installation begins, that they understand that that's part of the site conditions. Vegetated swales, they're not so difficult as far as in front of the wall. You might see them more, say, at the tops of walls, where you're catching hillsides, things of that nature, where you're trying to sort of infiltrate on a hillside, right? But also collect and divert some of the water. So it will be, the details with segmental retaining walls will be very similar to the permeable pavement applications. The challenge will be on the wall contractor to maintain minimum swale dimensions at the top, at the wall steps, as the wall is stepping with the swale or the hill or whatever, without reinforcing with the wall reinforcement. So the wall reinforcement is going to have to step as these elevation changes happen along the tops of the wall. You'll see here that they actually have a specific slope. They might have a minimum thickness, a material, soil amendments, those types of things. And those are the types of details that additionally you need to keep an eye out for as we're going through these project progressions. So we developed another detail for a vegetated swale at the top of the wall. A lot of time there might be a railing or a fence placed directly behind the wall. This certainly will need, you can't have a minimum, the minimum thickness is probably of the biomass media is probably going to be very slim. It's not going to be 18 inches. We state that it shouldn't be no more than 1 foot thick. Whether or not you can achieve that in this particular, type of application, it's going to be very difficult, and maybe it just isn't going to work for that particular area to have a bioswale. You will need an impermeable liner, and it's going to actually be directed to slope away from the top of the wall. There's going to be at least a minimum 2% slope, and we're going to have some type of additional drainage media in this area to prevent water. And this will have probably a minimum distance of a wall height away for the liner to prevent water from coming in contact with the back of the wall. And that'll hopefully limit the amount of drainage provisions that are necessary. Technical references. So we have a variety of information available to you along with these biomedia details. We have our new Keystone QL Pro retaining wall operating guide, our construction manuals, technical information sheets, specialty applications, typical CAD wall details. We recently uploaded a lot of our video resources that we've been doing the last 8 months or so. We have our previous webinar up there. We have an older webinar we did in 2016 on there. We have our QL Pro webinar, and we're going to upload this one up to our website along with that YouTube page. So we also have our short series we call Tech Talks, which are little short, basically less than 15-minute videos on common technical questions that we receive in our engineering department and how to address certain topics. So there's 7 topics that we've done so far. They're quick little hitters that you can go to that explain some of these details that we talk about and some other helpful hints and tools for handling, say, something like terrace walls. Here's a showing the YouTube page and also some various types of specialty videos that we do for some of our residential areas. We do have some time left for some questions, and so I'm going to let Keith take over from here. And here's the continuing ed credit line, that how to receive your continuing ed credit for this webinar. And thank you for your time and joining us today.
Thanks, Dan. Stay on the line. I'm going to ask you the questions. We had a few good questions here. Sure. First question is going to be detail availability. Where can they find these details?
Details can be requested from me or Keith. We don't currently have them posted to our website, so they are kind of sort of they're not widely used. Low impact development is not widely used with our walls, so we haven't necessarily put them out there, but we have those details available in CAD and PDF format. Okay. That we can email, so we can include that if they want copies of this presentation. If they want copies of the details, we can all include that in the same email.
And like a couple people stated in questions, is they are kind of dangerous when you get into these type of applications because a thorough understanding of what you're trying to do is very important to how the detail gets played out so it can be constructed correctly. Dan, another question: what are the options for development if there is not 10 plus feet from the SRW to the bioretention area?
Well, from our standpoint, unfortunately, you probably well, it depends on what your cost offsets are going to be, right? If maybe in this particular section where you have to support the biomedia, you're putting in a small segment concrete wall where the biomass is directly behind the wall, or something like that, where you need to have it closer. You can put in a concrete wall for this particular stretch or section of it. Now, that would be probably a question for a structural engineer, whether or not they want to have that contained behind their walls as well. But something along those lines, you know, the liners are a good potential possibility, but every project is going to be site specific. Really having those close to the wall is going to be very difficult from a segmental retaining wall standpoint, from the fact that we rely on the geogrid for our reinforcement and support. And so you can't, if you have these large mass media directly at the back of the wall, we got to have a grid layer in that upper 20 inches to be effective with the 8-inch high 1 square foot units.
Okay. Question here, Dan, is Dan's examples are eye-opening. Is it reasonable, possible to submit all designs to Keystone for review prior to issuing the drawings?
Well, we certainly, I mean, if you have questions regarding low impact development, things like that, we can take a look at things that are, you know, we can help out civil engineers and things with their plans prior to that with regards to the retaining walls. Now, are we going to be able to do everything, every site across the country? That remains to be seen, but we certainly have the capability to help out and make recommendations for, you know, a particular application you're looking at, and provide some peer review comments, and then have you work forward from there. We do a lot of education of other designers with respect to these types of issues that we make note of in the presentation. And so we want to help pass the word out that it's getting out there. And as we get the word out more, the industry as a whole will be better off noting that those are going to be types of things that can happen. And we want to help prevent that.
Okay. I got time for, I think I can get two more in here. Dan, what happens when the drainage layer has to be removed or replaced? This was an earlier example that you had. Shouldn't you deepen the design and design the wall for a worst case maintenance situation?
I would say that's probably up to each designer, but you could. I haven't found, I'm unaware of any cases where the actual drainage layer had to be replaced. It sort of depends on, so obviously the detailing, right? Would I recommend, if you're going to have a wall in front of it, maybe having a filter fabric layer between the sand bedding layer and the structural 57 stone layer? Probably. That way you can just sort of replace the sand media or the biomedia, the sand filter, and the filter fabric. You don't have to necessarily maybe replace the 57 stone. Now, maybe some designers out there have a little bit more experience with this, and that they end up replacing the drainage layer as well, the structural layer that's sort of supporting the biomedia. Then I would say in that case, certainly probably going to have to go make sure that the base of the wall is actually below the bottom of that as well. I think right now we have it level with the leveling pad, but if they're going to, in any case, if they find out that the maintenance is going to be below the actual base course of the wall needs to be below, the bottom of the base course needs to be below that sort of maintenance cutoff line.
Yeah. Last question here, and then we'll wrap it up. For walls with large slopes above 2-to-1 or 3-to-1, do you recommend a swale behind the wall to divert runoff to the end of the wall or to a catch basin, or would you increase the drainage stone behind the wall to collect that runoff and carry it away via the wall foundation drain?
Multi-point question there. So when we talk about swales behind the walls, so there's a couple of things. Number one, if the back slope is it's a level, let's say it's totally level all the way across the wall, you wouldn't put in a swale to catch the water. It doesn't have a means to drain, a means to go anywhere, and so then the water is either going to infiltrate or it's going to come over through the top of the wall. If there is a point in the wall that is a high point, and you can do a sort of vegetated swale or self-containing swale that drains to that can drain to the ends of the wall, and you have a means of collection, by all means, that could be a recommendation. Is it based on each site that's required? But if it's at that point where you have this kind of perfect peak in the middle of the wall, you might be able to get away with just doing it. Letting the back slope do the work again as well. But swales aren't generally necessarily recommended. They might come from the county as recommendations for what they require for hillsides and those that nature, but we wouldn't necessarily recommend it. But each application is certainly different.
Well, thanks everyone for attending. Thank you, Dan, for the great presentation. Send us the email. Send me the email at keith.miller@keystonewalls.com for the PDH credit. If you have any questions regarding any of this, feel free to reach out to us at a later date. If you have questions that are pertain to like a little tech talk series like Dan talked about, we can do that. Or another webinar, let us know, and we'll get going on that. Thanks a lot, and look for the presentation on our YouTube page probably first part of next week. Thank you. Have a great day.